And it's going to be this port. Okay, and let's look just for ARP. Okay, so server 1 is going to clear its cache. So let's go to the CLI and let's say ARP -D star. Okay, it's deleting the cache. And then we're going to ARP for the destination. So we're going to ping 11.00.12. Okay, we should see from the packet capture that what the server first said is, I am trying to reach 11.00.12. I don't know who owns that address. Does someone else know in the network who owns this particular IP? But the key here is that if we look at the layer 2 format of the frame, okay, so let's open up the actual ARP, and it says that the source address was server 1, okay, so all zeros and a 1. Destination address was a broadcast, okay, because we don't know where that destination is. Okay, then inside of the actual ARP payload, it talks about what specific protocol, okay, because ARP is its own protocol on its own technically. So it says you're trying to ARP for IPv4, this is the source MAC, this is the source IP. We don't yet know the destination MAC, that's what we're trying to find out. We do know the target IP, okay, we ARP for 11.00.12. We should then get the reply. Okay, the reply now, let's close some of these up, let's look at just the headers. The reply is saying it came from the source of server 2. The destination was server 1. Or in other words, it was a unicast reply from the destination back to the originator, because the destination implicitly knew the mapping between the IP address and the MAC address. Okay, that's why when we looked at the first portion of the exchange inside the ARP request is purposely populating the source IP and the source MAC of who generated the frame. Now, you might have someone in the middle that's re-encapsulating it like some sort of proxy device, okay, where in this case we have the VTAPs that are putting it inside of the VXLAN, but the point of this is that the unknown traffic only goes one way. Okay, it floods as broadcast out, it comes as a unicast back in. Now, from a VXLAN point of view, and a specific VXLAN implementation, this means that one way that we could solve this problem of figuring out who are the tunnel endpoints that own the addresses are just to flood the ARPs everywhere. So you send it on every single port on the leafs to the spines, on every single port from the spines down to the leaf, run some sort of loop prevention logic. Okay, specifically the loop prevention logic would be taken care of by multicast, but we'll come back to that later. And the ARP gets there, the reply comes back in. Now, in addition to this, the key would be that when the ARP is coming into the VXLAN network, okay, and I would have to see, let's do this. Let's go to the one that is capturing the payload of the VXLAN, and let's see what ARPs it got. Okay, it did get that communication between the two of them. Okay, so this was who has 11.00.11, tell 11.00.12. So this is 11.00.12 ARPing for server 1. Now if we look at the encapsulation of this though, notice that the ARP is being encapsulated inside of VXLAN. Now the destination address is 10.0.0.1. It's a unicast back to the person that sent the request to begin with, because from the router's point of view, okay, the switch in this case, this information is already pre-populated in BGP. Okay, in the other example I was talking about where you just flood the traffic everywhere, that's called VXLAN flood and learn. We would not have already known where the endpoint is located. So you would just flood all the traffic out, eventually figure out which MAC addresses belong to which VXLAN tunnel endpoints, because when this ARP request is being encapsulated, okay, so if we look at from the Ethernet point of view, and let me try to, let's do this. Let's restart the capture. Let me ARP for something that is not an actual valid address. Let's ping 11.00 whatever, 123. Okay, that's going to cause this guy to constantly ARP. It's saying who has 11.00.123. If this network is properly set up, what we should see is that And let me remove my capture. Let's see, are we getting anything? Uh-oh, what changed on this guy? Let me restart Wireshark here. Okay, and we're looking for ARPs. So we're not getting anything. Okay, the reason why is this is one of the optimizations of VXLAN. We'll talk about in more detail what the different knobs that you can turn are in order to change this behavior. But the idea is that the server's ARPing, it goes to the leaf. The leaf doesn't know where this destination is yet located. So you would figure, well, hey, if you don't know this, you should probably ask the rest of the network, right? You should send a broadcast out and say, does anybody have this particular destination? Okay, which is exactly what the server is doing. The server is saying, who has 11.0.0.1.2.3? I need to know. The problem is that the router on the VXLAN side is not doing this. We can see this based on the fact in the capture inside the underlay fabric is not seeing this message. Okay, just like we saw in the ICMP before, if we filter this to say we want to look at ICMP, we should see, and let me regenerate the traffic again. So from server 1, we do just a regular ping. This ping should have been captured. And then if we look at this guy here, we can see in the payload the protocol was what? VXLAN. So the regular unicast between the two servers is working. But in the case where I'm ARPing for the other destination, that frame is just getting thrown away. Okay, the reason why is that with the BGP implementation of VXLAN, the idea is that Leaf 1 knows about server 1. Leaf 2 knows about server 2. This information gets advertised into BGP. Somehow the messages get everywhere. Okay, so everyone now has the control plane synchronized. If an ARP comes in to Leaf 1, and if for some other MAC address other than server 2, okay, so we're assuming right now there's only 2 speakers in the entire topology. Okay, these speakers, going back to our simple diagram, are server 1 and server 2. Okay, this guy now sends the new ARP, and the new ARP is going for server 3. From 5K1's point of view, it has 2 choices. It can say, do I want to encapsulate that into VXLAN and send it everywhere, or do I just want to drop it? Now, since we're already running the control plane protocol BGP behind the scenes, it makes sense to drop the ARP as opposed to broadcasting it as like an unknown frame. And the reason why is that BGP is giving us an event-driven process of saying Leaf 2 owns server 2, Leaf 1 owns server 1, Leaf 3 owns server 3, and so on and so forth. And where we would see this, if we go back to the CLI, is going to be, if I can find my CLI, there it is, the show BGP L2 VPN EVPN for VNIs all, or for, how can I say all? Actually, I think just that. Okay, this is the actual encoding of the information. Now, as you can see, this is pretty complicated. Okay, we're going to come back later with a fine-tooth comb and talk about what are these fields and what do they specifically mean in the update. But the point being is that if we were to look at the BGP table and say, I want to look for a specific MAC address 001, I have that as a route. Or likewise, if we were to show the MAC address 002, I have that as a route. I know that the MAC address of, and let me clear this table, clear this out. You can see it's a pretty big output here. And what I'm looking for is the connection between this and this. that we're basically saying, from a BGP updating point of view, that server 2 is physically attached to 5K2. 5K2 is using the IP address 10.1.152, and this is a loopback 0 that's being used as the source of the tunnel. So the same as like in GRE, where you would say interface tunnel 0, IP, or tunnel source 1, 2, 3, 4, that's what we're doing here. Okay, in the specific implementation, this is done under the NVE interface. If we show run interface NVE1, it's the source interface is loopback 0. Okay, this is when we're advertising the information into BGP. We're saying, hey, my MAC addresses should be reachable via my loopback. The other leafs then, or the other VTEPs, wherever they are in the network, when they go to encapsulate the packet into the actual VXLAN data plane, they know where to send the packet destination to.